Welcome everybody. I'm Matt with DigitalOcean. This is Ceph operations at scale. So we'll talk a little bit about who we are at DO, the Ceph use, and we'll talk a little bit about our operating system in Ceph, how we define the line between the two. A little bit of cluster deployment, lifecycle maintenance, some observability, and wrap up with some Q&A. So a little bit about DO. These are some quick stats here. We're a cloud provider, public cloud. We launched volumes in 2016, 2017, and object storage about the year after that. Both of these things rely on Ceph for both the block and object workloads. And yeah, we've got 75 clusters. It's about 270 petabytes. 34,000 OSDs across 2,000 nodes. We store a couple bytes, and we can't be SSHing into individual nodes trying to perform maintenance when, upgrading a cluster, conducting routine maintenance, that sort of thing. It's just simply not feasible. It does not scale. So one of the ways we started to do this, back in the days of old, but not nearly as far in the past as I'd like to believe, we were running Ubuntu Trusty. We had Luminous packages. We were still running file store with EC on it, and this was not great. Anybody who's run that in the past knows it's not overly stable. We had a target for getting to Focal at the time with Nautilus. The path was difficult. That's a big change, a big blast radius. And we wanted to try to make that a little bit easier. And one of the easiest ways that we came up with to do this was to start the path to containerization. We weren't able to get a Luminous package, a Nautilus package with a newer, or with a Trusty OS at the time. And we just didn't want to try to upgrade both at once. So we started down the journey of containerizing Ceph, and this allowed us to worry about the Ceph layer without having to worry about the operating system at the same time. The OS upgrade process at DO is a lot more involved than you might think. We do a lot of firmware upgrade work for all the components. It's a bit tricky, so it introduces a lot of change. And this containerizing means we don't have to worry about the host OS. The kernel still kind of stays the same on the host, but it allows us to worry about the OS upgrade path later on. So there's some gotchas with the containers. We have a cloud operations team, and these are the 24/7 folks that maintain the resiliency of some of our clusters as we send alerts to them. They operate independently of us. We define alerts, we write the playbooks, we send these things off to these folks, and they're able to operate on these things. And we want to treat containers as an implementation detail. We don't want them to have to know that, especially during the path to deploying this, we don't want them to think that, this cluster might be containerized and that cluster might be with packages and have to interact with it differently. We've also written a bunch of scripts and a bunch of tooling that just kind of assumes that, you can just run Ceph-S. And we didn't want to have to change all that. That would be a lot of work. So we were able to instead just write some shims. We have a Ceph tools container on every host that runs Ceph. This thing is as simple as shown up there. It basically does a Docker exec into a Ceph tools container, runs what you want to run. We introduce shims for the Ceph command, the Rados command, RGW admin, crush tool, all these sorts of things. And this allows it to present itself as if it were installed on package, just natively available to the OS. We also have some systemd units, some systemd targets. These are for convenience. This allows us to be system cuddle stop, Ceph OSD target, shuts down all the OSDs on the host. And now with this, we can operate the cluster in the same way with packages and containers. This makes all of our playbooks for those cloud operations folks, we didn't have to change any documentation. So today, we have on the host, we can check the OS release. We've got Ubuntu. We can check the OS release within the Ceph tools container and CentOS stream because of the Ceph daemon base. And you can see that on the host, we have no Ceph packages installed. But if we do a witch Ceph, it'll still show our that user bin Ceph there is now a shim. So let's talk about some automation. There were some solutions available at the time when we deployed Ceph, but we were fairly early adopters. Ceph ADM, Orchestrator, Rook, Ceph Ansible. There are quite a few solutions available today that weren't as available or perhaps as mature as they are now back in those days. And in the early days, we hadn't deployed containers. So Rook was would have been a little frightening for us, maybe a little intimidating, and we weren't ready for Kubernetes at the time. Ceph Ansible has a very large scope. Everything that upstream needs to support, Ceph Ansible also needs to support. We don't need to support all of these things. DO has a use case that fits well inside Ceph. And it's a subset of its features. So the in-house solution was Storage CM. This is our configuration management. It's a collection of Ansible playbooks, roles, reusable, composable pieces that create said playbooks. This moves as fast as we do. It allows us to narrow our focus. So one of the things that is difficult for any kind of automation in this sense is the deployment path. Storage CM can be very opinionated about what deployment means. Deployment to DigitalOcean might mean something different than deployment to other folks. We can define what healthy means as well in the same way. So our use case is going to be different from many other folks' use cases, and we can make our automation reflect this sorts of thing. We can generate the crush tree for us. This crush tree will be generated from the Ansible inventory, which itself is generated from some tooling we have internally. We have a service that allows us to look up a whole bunch of hardware information about the nodes, their placement in racks, these sorts of things, which gives us all the information we need to create these crush trees. It allows us to integrate with our secrets store. That gives us keyring management. And of course, deployment is just the first step of the cluster lifecycle. We're going to have to maintain these things for many, many years. And we have some routine maintenance that we perform on all of our clusters, all of our nodes. The spiritual goal is going to be that we don't want to SSH into nodes if we don't have to. But of course, reality is that we do have to from time to time, but the automation tries to take most of that away. The more common thing that goes on is we have automated reboots across the fleet. And the reason for this is, well, there are a couple reasons listed here. There's an AMD errata about the 1044-day uptime that can affect specific AMD chips. This will cause the host to lock up. We don't really want to do that because we have a bunch of nodes deployed at about the same time. If they all kind of lock up at once, that's a product outage. That wouldn't be great. We don't know when the last time we read the superblocks for RocksDB off of an OSD. Rebooting the node, we get to find out ahead of time if there's some corruption there or some UREs that we won't be able to read from a disk. We'd rather find these out before it's a huge surprise. Finding these things out when the schedule runs to reboot these nodes during business hours means our on-call doesn't have to be woken up when there's some huge incident event, and then they also have to figure out why some OSDs won't start. The RocksDB superblocks are one of those things that just can't be scrubbed during the Ceph's normal scrubbing. So the automation can also check Ceph cluster health. Storage CM is very cluster aware. It's tightly integrated with our clusters, but the reboot, power off, shutdown commands, they're just going to do what you tell them to do. So if the cluster isn't healthy when we try to run any of these any of this automation, it's either going to fail or it's going to wait for the job to complete. So let's talk a little bit about safety. We use a Rados lock. It's primitive concurrency control in storage CM and some CLI tooling that we have. We don't know if we're the only ones working on a specific node in a cluster. We've got the cloud operations team who works independently of us. Of course, they can be running anything. The reboot schedule could be running. We may not be aware of that, but we still want to do things safely. So we fire off a job, it may fail, and say, hey, there's that lock description right there that we can give it, and it'll tell us, hey, there's an Ansible job running somewhere. When that job completes, it'll release the lock, and we can continue. This provides a lot of safety in our automation. So this lock is really important when we have other services also interacting independently. Consider, for example, a service that manages the lifecycle of an OSD. We might expect that to be fairly simple. New OSD comes in, or a new disk is inserted to a node, it becomes an OSD, we deploy it, it's happy for a while, it does its thing, and then, disks die. That would be a very straightforward state machine. The reality is, this is what our state machine looks like. It's kind of horrifying. It's a spaghetti graph there. This talk isn't really about how we built this, but why. There's nothing too crazy going on. Each of these states are kind of meaningful. And I don't want to hold all the context in my head, but the state machine and some automation can. This graph kind of represents the why we automated this. We built a service that's disk aware. One of the things you might notice here is there are no disks, or no arrows pointing towards disappeared. This is just because any state can end up in a disappeared disk. Disks can fall off at any time. But the point is, these states are very, very complicated, hard to remember. The transitions are difficult, and the service is a lot better at doing it than humans, even if we're invoking scripts. So there's some fruits of our labor here. This tooling can do a lot. There are three parts of it. There's a central service, which houses a database, which holds all of the stateful information. There's a daemon on the nodes, which interacts with all the disks, exports smart information, that sort of thing. And it can also interact with applications on the system, such as Ceph. And there's a CLI tool, which is able to interact with it. You can list all the disks, that kind of thing. And it's more than just Ceph-specific. It's capable of looking at OS disks, for example. It can operate on those independently, which also means that the central service is not aware of Ceph by any means. Included in some of this automation, we're able to find all of the history of the states of a specific disk. We're able to see that it moved through the state machine in a certain way. We can find this history. It's incredibly useful when we're trying to debug why a disk is in a certain state. It's a lot easier than digging through Jira tickets, for example, which is another thing this tool is able to do. This service is able to integrate with both Jira and Slack. It can create decops tickets, which we use to go replace the physical disks. There's one scary thing about this, though, and that's we're talking about automation that can destroy OSDs, recreate OSDs, and perhaps deploy them at inopportune times. We have, it's a huge investment. There's some safety here. We have some transition gating that allows us to make this a little safer. So a gated transition would say, for example, block us from deploying an OSD until an engineer approves it. This allows us to deploy it safely over time as we build confidence in the service. As said, the investment is absolutely worth it. Ultimately, what we're getting here, we're getting time. It allows us to do things like this, talks like this. It allows us to not spend our time doing a bunch of ops that a service could be doing, and it frees up those cloud operations folks to do bigger and better things. If I get paged in the middle of the night and I don't happen to fall down the stairs going to the laptop, I'm still going to be kind of squinting at a Ceph-S. I can type it with the best of them, but it's very easy to misinterpret some information and do something incorrect. The service is much less likely to do that unless I've written something very wrong. So with our scale, this service becomes very important. It's a case-by-case basis whether promoting some tooling up into a service that can do something like this is worth it. But again, with 75 clusters, more than 30,000 disks, we have failures every day. And it's a lot of toil if we aren't having a service do these things for us. So let's talk a little bit about observability here. We have Ceph Exporter. I'm not going to talk too much about it. This is overall cluster stats. We have it open sourced. It's on DigitalOcean's GitHub. We use this for many of our graphs. But there are 3 other tools that are internal that are quite interesting to talk about. We have Marigraph. This is for cluster latency stats. It's able to measure the latency for, say, an RBD image. This is something that runs internal to the cluster. It's a Go application, but it uses Go Ceph to talk to its RBD image, and it's a synthetic workload. It'll just continue making writes and timing them, exposing histograms, and we can get an idea of some of the write performance and read performance in a cluster. Store Exporter is another interesting one. It combines quite a few things, including reading data from the Ceph admin sockets. HV-block-D is one that runs on hypervisors, and this exports data from libvirt. This is something that uses the DOM block stats kind of thing to figure out how many writes a specific volume is doing. This helps us identify specific workloads if they become what we may consider abusive. If it's affecting other customers, we might need to identify a specific workload, and that would be how we'd go about it. So Marigraph has graphs that kind of look like this. We have the average latencies, the max latencies. We have P90s, 99s, and this P99 graph is particularly interesting because it allows us to see, even if we restart a single OSD, we'll see a little bit of a blip if we were to zoom in. We might have a bit of an increase in latency there. What we also get from Marigraph are these histograms. We get to see, not sure how clear it is on the graphs there, but we get some very tight bands at the bottom of the graph, and this kind of shows us the number of requests that succeeded in that bucket of time. This is what we like to see. Store Exporter, we get some information about Smart. Back when we wrote it, the Smart exporters weren't overly available, or everybody had kind of written their own. We also kind of did the same thing, but we wanted it to be very easy rather than just exposing the, power on hours happens to be, Smart attribute 9 or whatever it is. It's a lot easier to see this as a Prometheus metric that's named after something meaningful. We also expose the mediaware, for example, and this is aware of different pieces of hardware where vendors may present this data differently, whether it's a 0 to 100 or even a 255 to 0. We've had enough experience with these things to identify these and export them as metrics. And it allows us to alert when, say, a media wear is getting low. On flash devices, they can go quite a bit longer, but we have some spinners and we kind of set the alerts to like 97%, this thing's gonna die. This graph specifically shows when power out hours, it showed when a disk was replaced. So you can kind of see a line just kind of appears, and that's when the disk showed up. Also with Store Exporter, we get some metrics about network connectivity, specifically connectivity within the cluster. There's one dip here because that's a scheduled and automated reboot. Of course, when the node goes down, all of the other nodes stop seeing it. There are 10 nodes in this cluster, and for a moment, there were 9. This is the kind of thing that allows us to see when there are network events. This is particularly important in our wider clusters that are 4 racks wide. Store Exporter also shows the admin socket data. So this is a dump of the mempool information. So if we did a perf dump and we check the mempool for blue store alloc bytes, we'll get a number. We translate those dumps into an exporter for Prometheus, and we consume it, and we're able to check things like this. If we turn on the more expensive counters, we can get things like RocksDB stats, including latency, which is particularly important on index nodes as they get busier and busier. We can also use it to try to find fragmentation score information, which is very important as disks start to get a little more full, and you start to see, say, block devices have elevated latencies. And that's about all I've got for you. We've got some hiring plug here. If anybody has some questions, I'd be happy to take some on.
So Squid ships with a Ceph exporter. How different is yours?
So there's been a Ceph exporter in Prometheus as a module for quite some time. Ours was written well before that was available, and what we noticed when it became available was with every release, some of the metrics kind of changed. Our Ceph exporter is fairly consistent, though our newest release that we've got in production is Reef, so that's kind of where we ended. That's mostly what it comes down to, is it wasn't available when we wrote this, right, and we still needed it. I can't speak to what Squid brings. I don't know if it changes any of the metrics that we have. It might be a superset of what we have, but there may be a difference.
It's the source of the bucket metrics.
Store Exporter is also able to do some RGW stats, but we have yet another internal exporter that grabs a lot of things. We call it Object Logger. It's able to grab S3 ops for each bucket or user in DO land, and exposes requests per second, bytes in and out, that kind of thing. Again, built well before something like that was available. I didn't even know that's available. That is cool.
All right.
Thank you.
Thank you for the talk. I was wondering, did the automation cause any major downtime? Because it's pretty much possible, right?
Yeah, we test these things as much as we can in the lab, but of course no lab is ever representative of the workload you're going to find in production. I don't think we've found too many bugs in the automation itself, not ones that would cause outages, maybe ones that kind of expect a certain state that never happens, and then the automation's just like, I don't know what to do. And then we kind of have to pick up the pieces. The disk service that I had mentioned with the gating, certain states we can gate these things so that it doesn't take action until we hit the approve button. If we decline it, we'll go and file a ticket to be like, why did it want to do this? And then we build the confidence. We don't see that for a while. We remove the gate, and we start to trust the machine. For example, we still, in this path on the deploy and destroy paths, there's still a gate on each side just to make sure it doesn't destroy the thing we don't want it to destroy, and it doesn't bring it back at a wrong time.
Thank you.
Yes.
Could I please ask you to revert to one slide before with the nice graph?
Yep.
Is all those lines represent blue store alloc bytes?
Yeah, so that'll be each of the mempools. It's hard to see these graphs. So there's like OSD pglog, OSD blue store, cache data, that sort of thing. The orange line is the cache data, so something kind of interesting happened over the course of a day, and it looks like it happened 3 days before. But those are all the mempools bucketed by the pool.
Okay, thank you.
Yes.
Hi, Matt.
Hi, Kyle.
So, can you take us back to the slide where you showed us the state machine and I guess just the JQ output for Storeman CTL?
Starman Cuddle, that was a little bit after this.
Cool.
Yep.
So, yeah, so this will now store, I guess, a history of operational, I guess, interventions that have been taken on the disks for the cluster, right?
Yep.
Is there motivation for Ceph to be able to track that internally as well and have this registered as metrics so you can kind of tell, maybe cross-correlate between, introducing a new vendor into your cluster and, or, a disk vendor into your cluster and understanding if that correlates to a higher rate of operational interventions required?
Interesting. So you're asking if, make sure I get this right, you're asking if some of the state tracking information that's the service is doing could be embedded in Ceph itself.
Yeah. So you have like a time series that represents not only, that entirely internal to Ceph, maybe even exposed via the same exporters that you were talking about on, the other side of this. You can measure what impact operational interventions have on other metrics, as well as knowing the rate of operational interventions you have to do in the cluster.
I'm not aware of any efforts upstream that would be fairly interesting. Ceph is quite aware using, Ceph OSD metadata. It knows what kind of disk it is, that sort of thing. It gets some of the model information and be able to kind of track and maybe even aggregate some of this. It doesn't do it today. It's got the device health metrics pool that we don't use. But this service kind of aims to be able to do a lot of that aggregation for us over a long term.
Okay. And then one more question. Are there any other tools that you've shared today that you have aspirations or would be appropriate to open source?
Every one of them. I would love to be able to. It's a matter of time and effort. If I look at the, did I go too far? Yeah, it's observability. So Marigraph should be hopefully an easier one. We would like to do that one. We've talked about open sourcing Store Exporter in the past. It's a bigger lift than I think we thought of at first. HV Block D we haven't talked about yet. And with the other question I had just mentioned, Object Logger, that's really, that's something I haven't even considered open sourcing, but it could be something we'd look at. There's nothing overly secret or too DO specific about any of these things, but it is a matter of how big of a lift is it.
Thank you.
Yep. All right. Thank you very much.